Now that you've proven that you can turn both yellow and red light fractions into green light fractions successfully, you will never have to do it again when it comes to comparing fractions. In this video, you are going to learn an amazing comparing fractions shortcut called bottoms up. It should sound familiar, but if you're watching this video, it means you have my full permission to use it forever. Anytime you are asked to compare fractions, it is fair game for you to use. So, first things first, this shortcut is totally not needed if you are comparing green light fractions. Again, we know that these are green light fractions because they have the same denominator. The reason that this shortcut is not needed is because green light fractions are already quick and easy. You don't need a shortcut for something that's quick and easy. If the denominators are the same, then all you need to do to compare fractions is to look at the numerators, and the fraction with the greater numerator is greater. So in this case, 4/5 is greater than 2/5. With these green light fractions, all we have to do is look at our numerators to tell us which one is greater. Well, one side has 2/3, the other side also has 2/3, so that's why they would be equal. Again, green light fractions, it's already quick and easy. 5/7 is greater than 3/7. And last but not least, 4/8 compared to 6/8. Well, if I have 6/8, that would be greater. So this shortcut is not meant for green light fractions. This shortcut is amazing though, when you're trying to compare other types of fractions. If you take a look here, these are not green light fractions. If I label them, we're looking at both yellow light and red light fractions. We know yellow light's going to take a little bit of time to set up and turn into green light to compare, and we know dreaded red will take forever. So that is why this shortcut is amazing for yellow and red light fractions. Bottoms up, we were introduced to when we were checking to see if fractions were equivalent. Well, the same strategy will work to compare fractions. Let me show you. If I look at this first one, if I do bottoms up here and I say, okay, 2 times 9 is 18, throw that up in the corner, and we got to be organized. 1 times 10 is 10. You can see 10 and 18 are not equal. That's because our fractions are not equal. And to figure out which fraction's greater, we're simply going to look at 10 and we're going to look at 18. And since 18 is greater than 10, then that is my proof that 9/10, the fraction that is on the same side as 18, is greater than 1/2. So let's look again. I'm just going to try and do this. So we have 4 times 5 is 20. And going bottoms up the other way, 9 times 3 is 27. And what I know is 27 is greater than 20. And because the 27 is on the side of 3/4, then I know the fraction 3/4 is greater than the fraction 5/9. I'll do these quickly. 7 times 10 is 70. 11 times 2 is 22. Since 70 is greater than 22, then that tells me the fraction 10/11, which is on the same side as the 70, must be greater than 2/7. And what's really great is how much bigger 70 is than 22 is also going to tell you how much greater 10/11 is than 2/7. Because 10/11 has a much bigger number, that tells us 10/11 is not only greater, it's greater by a lot. Going through, 4 times 3 is 12. 6 times 2 is 12. You can see 12 is equal to 12. And that's how I know that these two fractions are actually equivalent. Finishing this off, 6 times 1 is 6. 3 times 1 is 3. And since 6 is greater than 3, I know 1/3, which is on that side, is greater than 1/6. And again, 6 is twice as big as 3. And that actually tells me that 1/3 is twice as big as 1/6. Pretty crazy. Finally, 9 times 3 is 27. 8 times 7 is 56. Clearly, 56 is greater than 27. So that's going to be how I know that the mouth should open to 7/9, because the fraction on the side with 56 is greater. So now that you've mastered doing it the long way, you have my permission to forever. When it comes to yellow light and red light fractions and comparing, feel free to use the shortcut.